Well, it's very nice to meet you, because I've been keen on interacting with schools and teachers probably for over 30 years. And well, I've worked for 40 years in Cardiff. And one of the interesting things about engaging is that when I started, there was quite a lot of opposition at the university. They said, well, you should only be doing research. What are you doing? You know, I said, well, actually, I believe two things. One is, if you love doing something, you want to inspire other people about it. So I've always loved exciting young people about what I do. But the other thing is, I believe universities have a huge responsibility. We're paid by public money to interact outside the walls that we've built up around us, to explain why we do what we do. So I'm going to give my story, and it's about a fantastic phenomenon which is scientifically called bioluminescence, life that sparkles. I've been lucky enough to work on it for 40 years. When I started, people said, this is crazy, why are you doing this in a medical school? You've been brought from Cambridge to do medical research and to develop new diagnostic methods. And we'll see, because amazingly, it has created billion-dollar markets. And one of them was the invention that I started to work with in Cardiff with colleagues there, which I'll tell you about. So let's have a look at this phenomenon. Here are 4 examples. The top left is a luminous jellyfish. This is called a sea pansy, which emits sort of greenish light, blue light. This is a sea cucumber, which emits blue light. And this is a very famous display in Southeast Asia. The male fireflies start flashing just after dusk, and they then synchronize, and the trees flash like Christmas trees. That's why it's called a Christmas tree display. We still don't know exactly how and why they do it, but nevertheless, it's another wonderful example of this incredible phenomenon. So we're talking about an ecology which we don't often think about, the ecology of the dark. Glowworms, fireflies, bats, moths, toads, there's a whole, badgers, there's a whole ecosystem out there, and as I shall show you in a minute. The biggest ecosystem on this planet is in the dark, and we're not worrying about enough because of the effects of climate change and global warming. So this is a session about entrepreneurship, so I put a few bullets in to try and relate my story to entrepreneurship. But please interrupt, we've got plenty of time, I'm sure. So do interrupt and ask questions. So an entrepreneur, me, is someone who brings together invention, innovation, business acumen to take a novel idea into the marketplace. So we talk a lot about innovation, but it's not the same as invention. Invention is what you start with, the idea, the proof of principle. You innovate to focus it and get it to work so that other people can use it, and then you have to take it into a business. So this is about curiosity. Why is this shrimp red? So when I give talks to kids about life that sparkles, I always ask, why is this shrimp red? We'll come back to that in a minute. Think about it, it's curiosity, and I think you'll find the answer is quite surprising. Now this is glowworm season, so I'm pleased to say that I do have one. How many people have not seen a glowworm? Only 2, everybody's seen them. 3, 4. Well, this is your lucky day, because I've been keeping these in the dark, and they are glowing. So if you'd like to, let me turn this on. If you'd like to pass those around, you'll see them. So those are the females. Now, I know how to make a glowworm first. So this session is about, I want to get you very excited, but it's your electrons I want to excite, because that's why they're emitting light. So if I can guarantee glowworms in July, but it's more difficult to find them. And of course that's the female glowing to attract a mate. in the female, but bioluminescence has a very distinct biological function, because in some species, including the glowworm, it has a different, I would say, selective advantage in different parts of the life cycle, so it's called sexual dimorphism. So in the males and the larvae, they flash, and although we don't have very good evidence, it's probably a way of detracting predators. It's a warning, because as Darwin found out, glowworms taste horrible. They produce a bitter substance, and birds learn not to pick them up. So this is the female, this is the male, these are the eggs, these are the larvae. This is a male displaying, and they eat snails and slugs. So I got curious about, 40 years ago, about why does a glowworm glow and a firefly flash? And why does a glowworm, British one, emit green light, and this American firefly emits yellow light? I'll just wait for this video to run. There we are. Classic pattern, 2 bars and 2 dots. And in a firefly meadow, when you get several species, the rate of flashing and the way they fly is species specific, so the males can recognize the females of the same species. But unfortunately, there's a femme fatale which flashes at the same frequency as another species. It attracts the male and then kills it. Now, one of the first things which is important to teach students, I'm sure you know, is to not just use common names, but to use systematic scientific names. Obviously, binomial. The British glowworm is Lampyris noctiluca, and that firefly is called Photinus piralis. But has anybody been to New Zealand? No. Well, if you go there, there's a very, very famous display in the Waitomo Caves, and it's called a glowworm. It's the larva which sits on the ceiling. But of course, the British glowworm is not a worm, nor is this a worm, nor is a firefly a fly. Glowworms in this country are beetles, whereas this, in fact, is a diptera, it is a fly. So these common names can give misrepresentation of exactly what type of animal you're looking at. So these are some of the British bioluminescent animals I work with. A jellyfish with its hydroid form, so it has a life cycle. I never used to teach that at A level, but of course no longer. This is the glowworm, and this is called a piddock. It lives in a rock, and it squirts out bioluminescence when you stand on the rock at night. And I know we've got somebody from IT here, so one of the things I want to bring out is that I'll be showing quite a few pictures and AVIs, videos. Some of them in real colour, which is what I showed at the start. Others are pseudo-colour. So this is pseudo-colour. So this is a brittle star, which is very commonly found around the Welsh coast. I got this one in Pembrokeshire. And its bioluminescence is taken with a very special camera I have, which images individual photons. It's one of the most sensitive cameras you can get. And the software converts the intensity into a colour. White is very bright, red is bright, yellow is less bright, blue is less, and then black is nothing. So when you see these, this is not real colour, it's pseudo-colour.